afternoon, everyone. So I've got a very exciting topic to talk about today, and how at Cisco we're looking at things a little bit differently. So what we're going to do is, I think we'll have a little bit of a backdrop to kind of get everyone on the same page, see what the problem is, and how Cisco's innovating to resolve this kind of issue, as we call it currently. So a little bit about myself. Not going to take long, don't worry. So yes, that's correct. My name is Mustafa. I'm a cybersecurity consulting engineer at Cisco. Been here about 8 years. My focus really was around content security. And in that time, I've kind of moved around, ex-penetration tester. And now I am actively helping customers to deploy a couple of key technologies around visibility in security. So let's get started. So what we're seeing today, and some of you guys can probably relate to this as well, is that networks are becoming more and more opaque. So what we see here is at the top is that, and this actual screenshot was taken at Mobile World Conference in 2018, and you can see there HTTPS, right, overrides all of the other kind of things, HTTP, DNS, and so forth. So a lot more traffic is actually going across the network encrypted. So what does that mean, right? So if you have a proxy in place today, right, you can't just proxy the entire internet, okay? Because if you think about it, how many boxes do you need to do SSL decryption, okay? The other problem that you're going to find is that more and more people are using applications. And in the days that we do it today, for example, when we're looking at HTTPS sites for threats, we have to have a certificate on the browser that you would own. And you become kind of a man in the middle, should we say. Now, with TLS 1.3 upon us, this is going to become extremely difficult. And the reason being is because those man-in-the-middle certificates won't exist anymore. So we need to start to think of different ways to start to look at this traffic from a security standpoint. Not saying about actually going through the traffic and packet sniffing, because that's useless to us. We don't need that. What we really need to understand is the threats that are in those packets. Now, also, if you think about it as well, what we're also seeing is hackers are using the same tricks as us, right? As we start to encrypt, so do they. They have access to the very, very same tools. When we're researching something, we go www.cisco.com, othervendors.com, and we look about it, we understand it, we set up a shell company, and an attacker now gets access to a product. So what they do is they actually start to use these products to test against their kind of exploits. We can also see about a 12% increase where there's actually malicious files going through our sandboxing system, threat grid, that are encrypted, okay? Because they know sometimes we don't look through that HTTPS traffic. We think it's protected. No one's going to touch that stream. So we're seeing a lot of also malware now being encrypted to evade sandboxing. So this opens up a pretty big challenge, okay? At Cisco, when we started to look at this issue, the thing is, like I said, we weren't interested in, what's inside, right? What we're interested in is to understand, is this file or is this piece of traffic that's flowing through my network ransomware? Is it crypto mining? Okay. And what we did was, with a couple of technologies within Cisco, we've created a pretty powerful solution called encrypted traffic analytics. Now, you can see here, so if I just get the clicker, you can actually see here, first off, on this side, if you follow me from here, where we've got leverage network and telemetry exporter, and I'm going to flow through this. And I'll tell you how it works. So what we have is telemetry data, okay? At Cisco, what we use mostly for this is NetFlow, okay? This is the byproduct that comes off your switches. You can take the telemetry pieces of data, so for example, source, destination, MAC address, things like that, and you can start to stitch that information together. You don't have to have sensors in your environment. You just basically need to feed off the net flow that's coming off. Now, what then happens is, as that information starts to flow through, we can do some standard baselining, and I'll talk a little bit of the technology in a second, but we can do some standard baselining with the StealthWatch piece. But what we also do is, if you have one of these products, like a Catalyst, an ISR, an ASR, a CSR, you can add 2 pieces of key information, which helps us understanding that flow of traffic a lot better. We then take that metadata, we stitch it all together, and then what we do, we send it to the cloud, which is called Cognitive Threat Analytics. Now, Cognitive Threat Analytics is our kind of machine learning, AI, all those cool buzzwords, should we say. And I'll talk about the technology as well of how it works and so forth with regards to supervised learning and unsupervised learning. So we bring that all together, and the key 2 pieces of information that we have, as you can see here, at a very high level, is that initial data packet. So before that first TLS stream happens, okay? The sequence of the packet lengths and times, and then we've got the global risk map. This is very much around, right, our intelligence. So you might have heard it in the earlier Cisco presentation, but we talked about Talos and so forth, and that brings everything together. All of our knowledge, our technology, our experiences, our innovations, okay, to build this amazing product. So Cisco is the only vendor today that can actually do this, and there's a reason why for that. Because we take those initial data packets, this is what we've created, okay, and you can see here at a very high level, we've got TLS header, TLS versions, SNI names, certificates, TCP headers, all that cool stuff to help us start to build a kind of a profile. Now, you're probably going to ask me, the server name is not in TLS 1.3. How do we deal with that? We're thinking about that. And we thought about it, and we've got a solution. What we're starting to do, again, leveraging machine learning and classifiers, we start to take that information and build based on previous network traffic, okay? Also based on a lot of the Talos intelligence as well. So we start to build classifiers and algorithms against that. So we take that initial data packet. Then what we do, we look at the packet sequencing, okay? The metadata. We know from the top, a Google search looks like this. We've seen it on the network. And I'm not just saying about your network, I'm saying across the globe, okay? This is what a Google search looks like. This are the traffic patterns of a Google search. We also know that a command and control channel has a specific traffic pattern, and so forth. And the system keeps on adapting and learning. And I'll explain why. So in all, this is what it looks like. So if you just follow the journey with me, what we can see starting from layer 1. So we take that anomalies, okay, and we start to bring everything kind of together. So we look at it and we go, right, okay, have we seen this before? This kind of traffic sequencing, matching up with the initial packet sequence, but also looking at the global risk map. The answer is no, we haven't. Moves along. So we start to build a trust model against it. What does that actually mean? So we say, is this, looking at this traffic, is it trusted? Is it doing something that's, known good or known bad? Okay. If it's doing something that's known bad, we then take it up and we compare it against a global risk map. So really, what we're looking at is, for example, if the device is connecting or if the packets are trying to go out to a certain IP address, if it's reaching out to a known bad kind of domain, URL, and so forth. We also, what we do is we take a lot of the information that's coming from our endpoints as well. So, for example, if we've got something like ransomware running in our environment, before the entropy, okay, of the scanning, as it starts to encrypt the machine, there's usually some files that are dropped to start that whole kind of infrastructure, that kind of encryption process. So we can pull those endpoints, and again, this might not be from your organization, okay? This might be from another organization where we can pull those key metadata pieces, okay? And then what we do is we start to build the event classification on top of that. And the reason why we model it and event it like this is that malware can change over time. So, for example, you've got ransomware. I've gone out. Let's say I'm a hacker, and I've decided, you know what, I don't want to spend the time building that code to do that. What I'm going to do, I'm going to go onto the black market, and I'm going to spend $200,000 and buy that payload. Okay? And then I'm going to adapt it. That's why we need the trust modeling. And we need the classification and the entity modeling on top, because malware changes. We have to adapt to that. From there, what we do, we look at relationship modeling. So over here, and this pretty much is the bit that brings all that pieces together, like various different vectors. So web, email, IPS, next generation firewall, and so forth. Again, we go back to the threat correlation. We go back to threat grid, and we start to analyze a lot of those key piece information points. And we start to pull that through. So then we can say with a high degree of certainty if this is bad or not. Okay? So again, this is what I was saying about with regards to the products and the intelligence that we see today. So there's a whole host of things, okay? And what is unique, specifically from this standpoint, is whenever you're fighting an attack, whenever you're looking at security, attackers play the dirty game. They're going to come in via an email, okay? So they've come in on one vector, SMTP. Then they're going to come in. You click on the email link. That email link goes to a URL. We're now talking about a different vector now. We're talking about a web vector. And then from the web vector, they've successfully downloaded the payload. The payload is on the machine, okay? That's where we look at endpoint protection. But then I can go further. I could even start to talk about fireless malware, where systems are now using what's on there, or attackers are using what's on there to actually run a kind of like PowerShell and evade those endpoint protections. So you need to look at memory protection, services protection with those endpoints. By gathering all of that intelligence, we can then feed that back in to ETA, okay, to know what to look out for. So here, just give you a quick overview, really. Again, we've got a lot of open source products as well, so like SpamCop, SenderBase. And what we see is the two most biggest attack vectors are always going to be web and email. Reason being is there's no patch for a user. They're going to always click on that link as much as you train them. You might actually reduce the link clickage, should we say, but you're always going to get this one user that's going to click on the link. My dad does it all the time. And this is just a breakdown, a very high-level breakdown of kind of the threat intel that we see today. This is all feeding that encrypted traffic analytics, the information key pieces as well. So the next thing you're probably going to ask me is, okay, this is all great. You've told me all this information. How does it actually get used from the cloud back down to the products? So what we've got here is crypto mining. So this is the modern-day version of adware. Okay? Those old ad injections in the iframes that you used to click. Well, this one's a lot better. It's a lot sneakier as well. The user doesn't even notice it. Okay, it's running in the background. The only way you'd ever realize is if you look on the services and see the processing power of the browser. So what we have is these are a range of products. Now, let's take an example that we found that there is some crypto mining going on. Our threat intelligence researchers found it. So how do we feed that back down into the products? What does it look like? Well, if you look at the very top first, what you can see is on the AMP for endpoints, as I was saying, an attack can be multi-vector. You've got Bitcoin miner and crypto miner. So these are the two kind of commands that are detected before the initial encryption. Okay? So again, prevention. Being able to stop it with these two commands. So we know that the AMP for endpoints can stop this at the initial encryption. Again, when we look at the indicators for threat grid, which is our sandboxing solution, identify the presence of the mining activity when the file sample is submitted. So it will actually run it, record it. It'll have a dirty and clean feed, as we call it. And we can actually monitor where those malware, where the actual indicators of compromise are, where it's being pulled from, where the botnet command controls are, where the hosts are, and so forth. Next generation IPS. Snort signatures. We can create snort signatures. We can stop it straight away. Okay? And umbrella and email security. Being able to block those bad domains. Okay? Now, I'm not saying this solution is completely bulletproof, right? But you've got a 99% chance of putting some effective defense in depth or layered security in place. And again, you can't go and completely decrypt the internet. Think about the applications that are running in your environment that are going over HTTPS now. And lastly, what I wanted to talk about was a tool that we have called Cisco Threat Response. So if you guys, I don't know if you listen to podcasts much, but we have a podcast called Talos Blogs, basically, or Talos, or Beers with Talos, as we call it. Now, the way it works is these guys, once a week to maybe twice a week, they go on the podcast, they talk about various threats and stuff like that. But also what they do is they actually document a lot of the threats that they find. And they document it on the blog. Okay? And what it is in that blog is a range of signatures, IP addresses, URLs, and so forth. So if you go there and you look at, for example, one of them was WannaCry. Let's take that as an example. You can actually go in and you can see it in the blog where everything's, what domains it's been connecting to, where it's going, and so forth. You can actually copy and paste within the blog, right, and straight into investigation. So what it does is it looks at your environment and it says, have I been infected? So if your boss comes to you and say, oh my God, did you see the news? It's like WannaCry. Are we infected? Who's got it? Right. 9 times out of 10, most organizations go, I don't know. Okay? So being able to quickly and powerfully copy, paste into here, new investigations, and it will map out if you've been affected or not. Okay? How does it do that? If it's purple, obviously these are the targeted machines. Associated files. Again, this is building that whole picture I explained around why it's important to look at each and every aspect of this. The file names that are associated with it. The paths that the file has traveled along. Because what you can do is, even if you're not a Cisco vendor, right? Even if you're not using a Cisco product, you can take these key pieces of information and you can start to push it out to your own antivirus solutions, to your own orchestration tools. Local sightings. So when did it hit me? And again, our global intelligence. So you can see here at the very top, obviously there's a severity which is high. Now, again, in this respect, it was malicious. We convicted it, which is fine. So the user's protected. But we're looking at virus total as well, just as a kind of a sanity check as well, right? Because there's a lot of unknowns out there. And again, visibility integration. So being able to actually drill in where the file went, the trajectory of that file. Now what you can do as well, it doesn't have to stop there. If I wanted to, I could take the SHA of that file as it passes through our system, okay? And I can actually put that into visibility and say, which of my files using AMP for endpoints, IPS, AMP for networks, web, email, has these systems touched? So you can start to build a better picture to quickly analyze and remediate. And again, lastly, on the threat grid. So being able to investigate the URL. Like I said, attacks usually start with the web and email piece. Okay? Being able to look at the IP address. So here it's not purple, so that means you've got no affected targets. You're good. But again, are you safe? So you have to be able to constantly check this. And you can, obviously using, again, defense in depth with other products, you can block this domain within Cisco umbrella. So being able to, one, understand the traffic as it's encrypted, okay? Know what it's doing, where it's going, but then taking that intelligence and putting it to good use as well. And this, what we find, speaking with our customers and the way the industry is changing, as we know, privacy is, for me as well and for everyone else, privacy is of the highest concern. And there's a lot of legislation in place and so forth as well, and it's going to be more, right, in the future. It's not going to kind of die off. This is where we're going. This is the route we're going down. So we need to think and innovate differently. And this is why Cisco is in a great position right now to show and to deliver this kind of solution. So we've got a couple of slides, which is around ETA. There was a few more, but hold on. But it seems like it's not there. But if you go to www.cisco.com/go/ETA, there's another one which I'll explain, which is blogs.talosintelligence.com. That's blogs.talosintelligence.com. And obviously, if you do a Google search, I don't know off the top of my head, but if you do cyber threat response by Cisco, it will show you that tool that I just explained to you now as well. But highly recommend it, ETA. Give it a go, test drive it in your environments and so forth. Thank you.